Good morning, students. Today we start our mathematics 1 lesson number 5, that is probability. So what is probability? See, suppose I have, this is coin. I have this coin and I toss it. What will happen? So we get two possibilities. First, that is head, and second, tail. So no other possibilities that obtained by tossing such coin. So this is probability. Probability means we get a probable answers when we do some actions, right? So let's check some important terms that we used in our probability lesson. So first one is random experiments. The experiment in which all possible results are known in advance, but none of them can be predicted with certainty, and there is equal possibility for each result is known as random experiments. See, we know in coin we have head and tail, right? See, we know in advance. So we know in advance that in coin it have head and tails, but we predicted, but we cannot say surely what will happen, right? So next one, outcomes. Result of a random experiment is known as an outcome. Outcome means, see, I toss that coin and see what will obtain, head coin. So this result is known as outcomes. So next, third one, sample space. See, next third one is sample space. The set of all possible outcomes of a random experiment is called the sample space. So this sample space is denoted by capital letter S, or this sign in a Greek we called it omega. So next one, sample points. So each element of a sample space is called a sample point, and it is denoted by number of S. It contains the element that we obtain by that sample space. Let's start with some examples first. See, suppose I toss one coin. See, I toss one coin. So what will happen? So we saw like that. See, sample space S is equal to, if we toss one coin, we get only head and tail, right? So we have to count the sample points. So H, that is one sample point, and T, second sample point. So we have number of S, that is sample point, is 1 and 2. So when we toss one coin, we get head and tail only. So then our number of S, that is sample point, is 1 and 2. Next example is when we toss two coins. See, two coins are tossed simultaneously. So we get sample space, right? See, take some example. This is first coin and this is second coin, right? So we have to write down sample space. For this we should done like that. See, this one H and this one H. So we have H. Next, this H and this T. So we have HT. Next, TH, and then TT. So these are the outcomes, and count them. First, second, third, fourth. 1, 2, 3, 4. So we have number of S is 4. Let's check out another example. Now, when we toss 3 coins. So, 3 coins are tossed simultaneously. Now, similarly, we add here next coin. Now, see, H, H, H. So therefore, sample space S is H, 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 then H, H, T. See, second one is complete, H, H, T. Then H, T, H, T, H, 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 T, 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 H, T, 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 H, and T, T, T. So count them. 1, 2, 3, 4, 5, 6, 7, 8. So, see, when we toss 3 coins, we get 8 sample points. That is H, 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 T, H, T, H, T, H, 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 T, 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 H, T, 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 H, and T, T, T. So these are the outcomes when we toss 3 coins. So let's move to our another example. Next one is 1 die is rolled. 1 die is rolled. So when we die means, see, if anyone played Ludo games or snake games, right? So in that we use the dice, right? So in that dice we have numbers. So that numbers consist 1, 2, 3, 4, 5 and 6 numbers, right? So count them and write down our number of S, that is 1, 2, 3, 4, 5, 6. Right? So now assume that we toss 2 dice are rolled. See, 2 dice are rolled. What happened? Assume in first die we have numbers. See, these are the numbers obtained on die 1. Same numbers are in die 2. Got it? Now start, write down sample space. C. Sample space S. In that we start with first die and repeat to second die. That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Now change first die 1 to 2. So start writing from 2 to 1, 2, 2, 2, 3, 2, 4, 5 and 2 6. Right? Next, change first die number. Now 3. So 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Complete. Then 4 number. First number change and second write down as it is. So now 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Right? Next 5 1, 5 2, 5 3, 5 4, 5 5 and 5 6. And start with last 6. 6 1, 6 2, 6 3, 6 4, 6 5 and 6 6. So complete. If you count them, we get number of S, that is 36. 6 in each, so 6 into 6, 36. So these are examples of probabilities that we actually use in our questions. See, probability of an event. In a mathematical language, when possibility of an expected event is expressed in number, it is called probability. So formula to find probability is P of A is equal to number of sample points in event A upon number of sample points in sample space, right? So we have formula P of A is equal to number of A upon number of A's. By using this formula, we are able to find out the probability of an event. So first keep in mind that probability maximum is 1. Probability is not more than 1. Always up to 1. It may be 0 but up to 1. Its values are between 0 to 1. So this is called probability of an event. Now move on to our next topic. Pack of cards, that is playing cards. Playing cards. Playing card is used to play club games or in casinos. So in a pack of cards there are total 52 playing cards. Total 52 playing cards. There are 4 types. So normally there are 2 types, that is red cards and black cards. There are main 2 types, red cards and black cards. So red cards are 26 and black cards are also 26. In red card we have 2 types, hard card, that is in heart shape, 13 cards. Then diamond cards, see, like this, diamond cards. These also contain 13 cards. So 13 plus 13, 26 red cards. Black cards. In black cards also we have two types. Spade cards. See, like this, in a black type of playing cards. And club cards. Club cards both contain 13s, and club card is like this shape, tree shape, right? So these are the total 4 type of playing cards we use. Red cards are 26. In red cards we have heart card and diamond card, and in black card we have spade card and club cards. Now face card. Face cards. So in playing cards we have Jack, Queen and King, right? Only 3 cards bear faces, right? Only 3 cards bear faces. So in each type contain 3 face cards, and total type is 4. So we have 12 face cards. So we have total 12 face cards. Then ace card. Ace cards means ekka card. So in all 4 types only 1 ace card. So total ace cards are 1 into 4, that is 4 ace cards. See, ace cards contain only 1, but it's not bearing any face. So face bearing cards only 3 in one type, that is Jack, Queen and King. See, heart cards contains ace card, then 2, 3, 4, 5, 6, 7, 8, 9, 10, then Jack, Queen and King. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total 13 cards. Same for diamond, same for spade and same for club. See, all same numbers will appear on all type of cards. So total we have 52 playing cards. Understood? So if you have any doubt, ask me. Okay? So next we start with some examples. Find the probability of the following events when 2 coins are tossed. Number 1 is getting head, number 2 getting tails, number 3 at least 1 head, number 4 at least 1 tail, and number 5 head on first coin. So we start our answer here. Our condition is 2 coins are tossed. Our condition is 2 coins are tossed. for this we have sample space, that is S, denoted by S, and answer is HH, HT, TH and TT. Okay, so count them: 1, 2, 3 and 4. So we have number of S, that is sample points, 4. Got it? Next, see, this our condition done, outcomes are ready. So we move to our events. So number 1 event, let, see, we don't, in question they don't mention us event number or event name, so we assume that event. So let event A is that getting hay, so this is the event. So event says that, so event A is that getting head. So we have to find only head in sample space. So write down first A and find getting head. Find getting head. So see, first HH, that is only heads are there. So we write down HH. Move on to our next sample point, that is HT. So our condition is getting only head here, right? So in this we have tail also. So this is not our right answer. Move on to next TH. In TH we contain T, that is tail. Our condition says only head. So this is not our answer. Then move to next TT, that is only tails are there. No head is there. So we exclude it. So we only have this HH. So count. So number of A is 1. Okay. We move to our answer. See, we find number of A. So we have to find probability of A. So how we find probability of A? We have formula. So we have the formula, that is number of A upon number of S. Now we have to put the values. See, number of A is 1. Number of A is 1 and number of S we have 4. See, these number, if divide them to the reduced form. If not, this is our final answer. 1 is not divisible by 4. So our answer is P of A is equal to 1 upon 4. Okay. So write down first. So our next event is getting tails. So assume first, let event B is that getting tails. Okay. So event B, we have to find tails. So check out sample space. So we have HH, HT, TH and TT. So condition says or tells us that getting tails. So only tails we have to find out. So here we get HH, no tails. Here tails, but we have to find only tails. So not right answer. This also is a not right answer. But this, check out fourth sample point, contains T and T, means only tails. In both places we get tails. So this is our answer. So write down number of B, that is 1. Number of B is 1. So we have to find probability of that event. So P of B, write down formula. So P of B is equal to number of B upon number of S. So number of B is 1 and sample point number of S is 4. Okay. So we write down 4. See, 4 not divisible by 1. So this is our final answer. So we write down P of B is equal to 1 upon 4. This is our final answer for event second. So next event, let event C is that at least one head. See, condition says us that at least one head. See, maximum head values, proper head values in 2 coin toss are, we get head 0, 1 and 2 times. Okay. See, here we get head 2 times. In both these we get head 1 time. And here we don't get any head, so 0 answer is there. Now we have to find at least one head. So at least meaning is minimum. We have to find minimum. Minimum one head means one head is required to find this event. So at least one head is required. So no, we cancel 0 means no head possibilities we reject it. So we have to find 1 and 2 heads. So check out in our sample space only 1 and 2 heads. So here we have 2 heads. So this is our correct answer. Here also we get 1 head. So this is our answer. Here also we get 1 head. So our answer is correct. For third and in fourth we don't get any head. Means 0 answer is there. So we cut it down, right? So our answers for event C, HH, HT and TH. So count them 1, 2, 3. Number of C, that is 3. Got it? Now we have to find probability for this. So P of C is equal to number of C upon number of S. So number of C we have 3 and number of S we have 4. So 3 upon 4 not divisible. So therefore P of C is equal to 3 upon 4. This is our final answer for event 3. Our next event is at most 1 tail. So let event D is that at most 1 tail. So our condition is at most 1 tail. In at most 1 tail we have to find maximum values for tails. So condition says that maximum means maximum 1 tail. At most 1 tail means maximum 1 tail. We have to find maximum 1. So in 2 coin toss we get again 0, 1, 2 values for tail. So condition says that at most 1 tail means we not found more than 1 tails, right? So we have to find values for T, that is 0 and 1, not 2. So let's find here. Check out our sample space. It contains HH, HT, TH and TT. So we have to find 0 and 1 values for t. Here we get 0 value for t. So it is our answer. Then here we have 1 value for t. See here 1 t is required. So write down ht. Again in third we have th. And last one we have tt value. That is 2 t's are there. It is not required in this our condition 4. So we exclude that value. So our answers are HH, HT and TH. So count them. Okay. We have values 1, 2, 3. Now we have to find probability for this event. So write down formula first. So formula is P of D is equal to number of D upon number of S. So number of D we have 3 values. So write down 3 upon number of S is 4. Again 3 and 4 not divisible by 4. So write down our answer 3 upon 4. So this is the answer for event 4. So our last event is head on first point. So let event E is that head on first coin. So head on first coin. See, in first we have head on first point. So write down this answer. Check out for second. See, here also we get head first. So write down. In third we have T on a first place. So our condition says that head on first point. So we cannot consider these values. And in 4 we have also T for first place. So we exclude both the values. And this is our final outcomes. So number of E is 2. Now find probability for this. P of E. So formula first write down formula. So number of E upon number of S. So we have number of E value, that is 2, and number of S is value 4. See, 2 and 4 after dividing we get 1 upon 2. 2 and 4 comes in 2 tables, so we cut it down. 2 1s are 2, 2 2s are 4. So we have value 1 upon 2. So P of E is equal to 1 upon 2. So this is our final answer for event 5th, event E. Thank you. So today's homework is you have to learn all the basics we studied earlier and revise this question. Okay? Thank you.